In economics, demand is the utility for a good or service of an economic agent, relative to a budget constraint. Demand is a buyer's willingness and ability to pay a price for a specific quantity of a good or service. Demand refers to how much of a product or service is desired by buyers at various prices. The quantity demanded is the amount of the product people are willing to buy at a certain price. The relationship between price and quantity demanded is known as the demand. The term demand signifies the ability or the willingness to buy a particular commodity at a given point of time. Overview: economists record demand on a demand schedule and plot it on a graph as a demand curve that is usually downward sloping. The downward slope reflects the negative or inverse relationship between price and quantity demanded. As price decreases, quantity demanded increases. Changing market price would move the equilibrium point for quantity demanded up and down along the demand curve, but would not shift the demand curve, and would not change demand for the good. An actual change in demand means that the whole curve of quantity demanded versus price has shifted. This curve is the demand, sometimes also called the demand curve. Change in demand and not just quantity demanded could come from changes in consumer wealth, from consumer preferences, or from the prices of substitutes or complements for the product. In principle, each consumer has a demand curve for any product that he or she is willing and able to buy, and the consumer's demand curve is equal to the marginal utility curve, assuming full information and a lack of frictions that would perturb the consumer's choice. When the demand curves of all consumers are added up, the result is the market demand curve for that product, which also indicates a negative or inverse relationship between the price and quantity demanded. If there are no externalities, the market demand curve is also equal to the social utility curve. Factors affecting elasticity of demand: innumerable factors and circumstances could affect a buyer's willingness or ability to buy a good. Some of the more common factors are: goods own price. The basic demand relationship is between potential prices of a good and the quantities that would be purchased at those prices. Generally, the relationship is negative, meaning that an increase in price will induce a decrease in the quantity demanded. This negative relationship is embodied in the downward slope of the consumer demand curve. The assumption of a negative relationship is reasonable and intuitive. If the price of a new novel is high, a person might decide to borrow the book from the public library rather than buy it. Price of related goods: the principal related goods are complements and substitutes. A complement is a good that is used with the primary good. Examples include hot dogs and mustard, beer and pretzels, automobiles and gasoline. Perfect complements behave as a single good. If the price of the complement goes up, the quantity demanded of the other good goes down. Mathematically, the variable representing the price of the complementary good would have a negative coefficient in the demand function. For example, QD equals a P, PG, where Q is the quantity of automobiles demanded, P is the price of automobiles, and PG is the price of gasoline. The other main category of related goods are substitutes. Substitutes are goods that can be used in place of the primary good. The mathematical relationship between the price of the substitute and the demand for the good in question is positive. If the price of the substitute goes down, the demand for the good in question goes down. Personal disposable income: in most cases, the more disposable income a person has, the more likely that person is to buy. Tastes or preferences: the greater the desire to own a good, the more likely one is to buy the good. There is a basic distinction between desire and demand. Desire is a measure of the willingness to buy a good based on its intrinsic qualities. Demand is the willingness and ability to put one's desires into effect. It is assumed that tastes and preferences are relatively constant. Consumer expectations about future prices and income: if a consumer believes that the price of the good will be higher in the future, he/she is more likely to purchase the good now. If the consumer expects that his/her income will be higher in the future, the consumer may buy the good now. Population: if the population grows, this means that demand will also increase. Nature of the good: if the good is a basic commodity, it will lead to a higher demand. This list is not exhaustive. All facts and circumstances that a buyer finds relevant to his willingness or ability to buy goods can affect demand. For example, A person caught in an unexpected storm is more likely to buy an umbrella than if the weather were bright and sunny. Demand function and demand equation. The demand equation is the mathematical expression of the relationship between the quantity of a good demanded and those factors that affect the willingness and ability of a consumer to buy the good. For example, QD equals F, P. PRG, Y, is a demand equation where QD is the quantity of a good demanded, P is the price of the good, PRG is the price of a related good, and Y is income. The function on the right side of the equation is called the demand function. The semicolon in the list of arguments in the demand function means that the variables to the right are being held constant as one plots the demand curve in space. A simple example of a demand equation is QD equals 325, P, 30 PRG plus 1.4 Y. Here 325 is the repository of all relevant non-specified factors that affect demand for the product. P is the price of the good. The coefficient is negative in accordance with the law of demand. The related good may be either a complement or a substitute. If a complement, the coefficient of its price would be negative as in this example. If a substitute, the coefficient of its price would be positive. Income, Y, has a positive coefficient indicating that the good is a normal good. If the coefficient was negative, the good in question would be an inferior good, meaning that the demand for the good would fall as the consumer's income increased. Specifying values for the non-price determinants, PRG equals 4.00 and Y equals 50, results in the demand equation Q equals 325, P, 30, 4, plus 1.4, 50, or Q equals 275, P. If income were to increase to 55, the new demand equation would be Q equals 282, P. Graphically, this change in a non-price determinant of demand would be reflected in an outward shift of the demand function caused by a change in the x-intercept. Devon Clark, Demand Curve. Demand curve is a graphical representation showing different quantities of a good a consumer is willing to buy at different prices, assuming no change in other factors influencing demand, is called a demand curve of that consumer. Return negative Rn equals R equals causes a turn equals causes of R to the slope. Th negative E slope of the demand curve is due to the diminishing marginal utility and the substitution and income effect. As the price falls, the number of units where marginal utility outweigh the marginal cost increases, thus it will continue to be a rational consumption for a larger number of units. The substitute effect is apparent because consumers will automatically switch to cheaper goods and move away from higher-priced goods due to limited income and the desire to maximize their utility. When a good's price changes, a consumer's real income will be affected. In the case of a price decrease, they have greater purchasing power and their real income has increased. With this extra purchasing power, they are able to buy more and usually do. Return negative Rn equals R equals causes a turn equals causes of R to the slope. Th negative E slope of the demand curve is due to the diminishing marginal utility and the substitution and income effect. As the price falls, the number of units where marginal utility outweigh the marginal cost increases, thus it will continue to be a rational consumption for a larger number of units. The substitute effect is apparent because consumers will automatically switch to cheaper goods and move away from higher-priced goods due to limited income and the desire to maximize their utility. When a good's price changes, a consumer's real income will be affected. In the case of a price decrease, they have greater purchasing power and their real income has increased. With this extra purchasing power, they are able to buy more and usually do. Return negative Rn equals R equals causes a turn equals causes of R to the slope. Th negative E slope of the demand curve is due to the diminishing marginal utility and the substitution and income effect. As the price falls, the number of units where marginal utility outweigh the marginal cost increases, thus it will continue to be a rational consumption for a larger number of units. The substitute effect is apparent because consumers will automatically switch to cheaper goods and move away from higher-priced goods due to limited income and the desire to maximize their utility. When a good's price changes, a consumer's real income will be affected. In the case of a price decrease, they have greater purchasing power and their real income has increased. With this extra purchasing power, they are able to buy more and usually do. Price elasticity of demand. PED is a measure of the sensitivity of the quantity variable, Q, to changes in the price variable. P. Elasticity answers the question of the percent by which the quantity demanded will change relative to a given percentage change in the price. For infinitesimal changes, the formula for calculating PED is the absolute value of a, PQ. Determinants of PED. The overriding factor in determining PED is the willingness and ability of consumers after a price changes to postpone immediate consumption decisions concerning the good and to search for substitutes. Elasticity along linear demand curve. The slope of a linear demand curve is constant. The elasticity of demand changes continuously as one moves down the demand curve because the ratio of price to quantity continuously falls. At the point the demand curve intersects the y-axis, PED is infinitely elastic, because the variable Q appearing in the denominator of the elasticity formula is zero there. At the point the demand curve intersects the x-axis, PED is zero, because the variable P appearing in the numerator of the elasticity formula is zero there. At one point on the demand curve, PED is unitary elastic, PED equals 1. Above the point of unitary elasticity is the elastic range of the demand curve. Below is the inelastic range, in which the elasticity is less than 1. The decline in elasticity as one moves down the curve is due to the falling PQ ratio. Constant price elasticity demand, where A and C are parameters, and the constant price elasticity is C and market structure and the demand curve. In perfectly competitive markets, the demand curve, the average revenue curve, and the marginal revenue curve all coincide and are horizontal at the market-given price. The demand curve is perfectly elastic and coincides with the average and marginal revenue curves. Economic actors are price takers. Perfectly competitive firms have zero market power. That is, they have no ability to affect the terms and conditions of exchange. A perfectly competitive firm's decisions are limited to whether to produce and if so, how much. In less than perfectly competitive markets, the demand curve is negatively sloped and there is a separate marginal revenue curve. A firm in a less than perfectly competitive market is a price setter. The firm can decide how much to produce or what price to charge. In deciding one variable, the firm is necessarily determining the other variable, inverse demand function. In its standard form, a linear demand equation is Q equals A, BP. That is, quantity demanded as a function of price. The inverse demand equation, or price equation, treats price as a function G of quantity demanded, P equals F, Q. To compute the inverse demand equation, simply solve for P from the demand equation. For example, if the demand equation is Q equals 240 minus 2P, then the inverse demand equation would be P equals 120 minus 0.5 Q, the right side of which is the inverse demand function. The inverse demand function is useful in deriving the total and marginal revenue functions. Total revenue equals price, P, times quantity, Q, or TR equals PAR, Q. Multiply the inverse demand function by Q to derive the total revenue function, TR equals A, Q equals 120 Q, 0.5 QA squared. The marginal revenue function is the first derivative of the total revenue function. Here Mr equals 120, Q. Note that the Mr function has the same y-intercept as the inverse demand function in this linear example. The x-intercept of the Mr function is 1/2 the value of that of the demand function, and the slope of the Mr function is twice that of the inverse demand function. This relationship holds true for all linear demand equations. The importance of being able to quickly calculate Mr is that the profit-maximizing condition for firms regardless of market structure is to produce where marginal revenue equals marginal cost. To derive MC, the first derivative of the total cost function is taken. For example, assume cost, C, equals 420 plus 60Q plus Q2. Then MC equals 60 plus 2Q, equating Mr to MC and solving for Q gives Q equals 20. So 20 is the profit maximizing quantity. To find the profit-maximizing price, simply plug the value of Q into the inverse demand equation and solve for P, residual demand curve. The demand curve facing a particular firm is called the residual demand curve. The residual demand curve is the market demand that is not met by other firms in the industry at a given price. The residual demand curve is the market demand curve D, P, minus the supply of other organizations, so, P, Dr. P, equals D, P, so, P, is the demand curve for PC firm really flat? Practically every introductory microeconomics text describes the demand curve facing a perfectly competitive firm as being flat or horizontal. A horizontal demand curve is perfectly elastic. If there are n identical firms in the market, then the elasticity of demand PED facing any one firm is PEDM equals NPEDM, PES. Where PEDM is the market elasticity of demand, PES is the elasticity of supply of each of the other firms, and is the number of other firms. This formula suggests two things. The demand curve is not perfectly elastic, and if there are a large number of firms in the industry, the elasticity of demand for any individual firm will be extremely high and the demand curve facing the firm will be nearly flat. For example, assume that there are 80 firms in the industry and that the demand elasticity for industry is -1.0 and the price elasticity of supply is 3. Then, PEDM equals NPEDM, PES, PEDM equals 3, PEDM equals -1, 80, PEDM equals -80 minus 237 equals 317, that is the firm PED is 317 times as elastic as the market PED. If a firm raised its price by 0.1%, demand would drop by nearly 1/3. If the firm raised its price by 0.3%, the quantity demanded would drop by nearly 100%. 0.3% marks the effective range of pricing power the firm has, because any attempt to raise prices by a higher percentage will effectively reduce quantity demanded to zero. Demand management and economics. Demand management in economics is the art or science of controlling economic or aggregate demand to avoid a recession. Such management is inspired by Keynesian macroeconomics, and Keynesian economics is sometimes referred to as demand-side economics. Different types of goods demand. Negative demand. If the market response to a product is negative, it shows that people are not aware of the features of the service and the benefits offered. Under such circumstances, the marketing unit of a service firm has to understand the psyche of the potential buyers and find out the prime reason for the rejection of the service. For example, if passengers refuse a bus conductor's call to board the bus, the service firm has to come up with an appropriate strategy to remove the misunderstandings of the potential buyers. A strategy needs to be designed to transform the negative demand into a positive demand. No demand. If people are unaware, have insufficient information about a service, or due to the consumer's indifference, this type of a demand situation could occur. The marketing unit of the firm should focus on promotional campaigns and communicating reasons for potential customers to use the firm's services. Service differentiation is one of the popular strategies used to compete in a no-demand situation in the market. Latent demand. At any given time, it is impossible to have a set of services that offer total satisfaction to all the needs and wants of society. In the market there exists a gap between desirables and the availables. There is always a search on for better and newer offers to fill the gap between desirability and availability. Latent demand is a phenomenon of any economy at any given time. It should be looked upon as a business opportunity by service firms, and they should orient themselves to identify and exploit such opportunities at the right time. For example, a passenger traveling in an ordinary bus dreams of traveling in a luxury bus. Therefore, latent demand is nothing but the gap between desirability and availability. Seasonal demand. Some services do not have an all-year-round demand, they might be required only at a certain period of time. Seasons all over the world are very diverse. Seasonal demands create many problems to service organizations, such as idling the capacity, fixed cost and excess expenditure on marketing and promotions. Strategies used by firms to overcome this hurdle are like, to nurture the service consumption habit of customers so as to make the demand unseasonal, or other than that firms recognize markets elsewhere in the world during the off-season period. Hence, this presents an opportunity to target different markets with the appropriate season in different parts of the world. For example, the need for Christmas cards comes around once a year. Or the seasonal fruits in a country. Demand patterns need to be studied in different segments of the market. Service organizations need to constantly study changing demands related to their service offerings over various time periods. They have to develop a system to chart these demand fluctuations, which helps them in predicting the demand cycles. Demands do fluctuate randomly, therefore, they should be followed on a daily, weekly or a monthly basis. See also, demand chain, demand curve, demand schedule, derived demand, planned obsolescence, law of demand, law of supply, supply-side economics, supply and demand, utility, notes. Further reading, Bar, Al. Supply. In David A. Henderson. Concise Encyclopedia of Economics. Indianapolis, Library of Economics and Liberty. ISBN A978-0865976658. OCLCA 237794267 Henderson, David A. Demand. Concise Encyclopedia of Economics. Indianapolis, Library of Economics and Liberty. ISBN A978-0865976658. OCLCA 237794267 Friedman, Milton. The Marshallian Demand Curve. Journal of Political Economy 57, 463 doi, 10.1086/256879. JSTORA 1826553A, A section.